Hello and welcome back to Calculus 1, section 3.10, derivatives of inverse trig functions. We know 6 trigonometric functions and their derivatives. So derivative of sine is cosine, derivative of cosine negative sine, and so on. Now we want to see what are the derivatives of the inverse sine, inverse cosine, and so on. If you recall, y is equal to sine x, which was the, if you draw just 0 to pi, so 2 pi, sorry, 1 period of sine, that was the function. And it's actually on the infinite domain, so it's infinite wave going on. And now you take the inverse. The inverse asks you to swap domain and range and then solve for y. So we apply the inverse sine to both sides, and we get that y is equal to sine inverse of x. Those of you from other countries and different education, probably you've seen it this way also, arc sine of x, which is much better notation than the negative one. So that would be the inverse, and then the associated graph would be like this. Now we immediately see the issue. Well, we've seen the issue earlier. The horizontal line test fails, which means that the inverse is not a function. So what we do is we restrict the domain. When you go y equals sine x, you restrict domain from negative pi over 2 to positive pi over 2, and that will give you the squiggle like this. Now this passes horizontal line test, and the inverse on the restricted domain, which is inverse like this, would look like this. So your negative pi over 2 to pi over 2 and negative 1 to 1 would now flip, and you would have negative 1 to 1 on x-axis and negative pi over 2 to pi over 2 on y-axis. Should have drawn those bigger, so there you go. If you feel in your mind, see how it curves. It curves to continue this way, and over here curves to continue that way. So be careful with the curvature that you are using. Now, we see that we have these, we understand what the inverse is, and also one more thing, for purposes of calculation for the problems with the tangent lines, right, that you all love so much, I will remind you that sine of pi over 2, let's go pi over 6, is 1/2, and the inverse of 1/2 is pi over 6. So technically, sine of an angle is a number, and inverse sine of a number is an angle. And you have the examples next to it. Now that goes for all 6. The derivation using the implicit differentiation and all of the other bells and whistles, the proof for these formulas, they are in a book if you're interested. Again, we're not in the honors section here. If you want to look at that, also please stop by my office hours and ask questions if you have any on those derivations. I'm going to list 6 formulas that we need to know for derivatives, and I will point out which 2 formulas are going to be frequently featured in your Calc 2 and differential equations. Right? The other 4 are rarely present after this course. So we start with the derivative of inverse sine of x, right, which is 1 over square root of 1 minus x squared. So that would be the inverse sine. Then we have the derivative of inverse tangent, which is 1 over 1 plus x squared. And we have the inverse secant. Now this one features the absolute value, so you have to be careful. It's not there for decoration. You have to use this absolute value. So these are the three formulas. And now the other three are the same, except you put the minus in front of each one of these. So the derivative of cosine inverse of x is going to be negative 1 over the square root of 1 minus x squared. So you just copy everything and put the minus in front of each one in the numerator. So it's extremely easy to get all 6. Oh, I'm missing x over here. There we go. So cotangent is going to be negative 1 over 1 plus x squared. And finally, the derivative of cosecant inverse of x is negative 1 over absolute value of x, square root of x squared minus 1. And I can put this on a cloud. You know what? I'm going to put these two on a cloud. So those two formulas you are going to see as you take future courses. And if you between two of them, you're going to see inverse tangent about 80% of the time and inverse sine about 20. All right, so there's a heavy emphasis here on the inverse tangent. But these are all 6. Now, I will pick a random formula, let's say cotangent inverse. And make it better. Because we can. It's not cotangent inverse of x, it's cotangent inverse of any function. And a cotangent inverse of any function is going to be negative derivative of that any function divided by 1 plus function squared. So I hope you see the same structure of negative 1 over 1 plus x, right? 1 plus x squared. So if you look at this, it's the same structure. You have that times the chain rule, which if you consider here, f of x is x, the derivative of that is 1. So it fits, it still fits. So I will encourage you to go and rebrand all 6, right, using the f of x rather than x. And obviously you have to multiply by f prime each one. So each one of these 1s in the numerator will be replaced by f prime because it has to be times the chain rule of whatever is in there. And then each x is replaced by f of x. So this one would be f of x and f prime on top, so on. Just do 2 or 3 examples and we're done. This is extremely short. The book takes its sweet time to go through derivation of these. If you are interested, please look at those. And for the exam, you can expect to see something like derivative of inverse tangent of, say, x squared minus 3. So now you see that you have a function over here. So you would recall the inverse tangent formula, but used with a function as f prime divided by 1 plus f squared. And you just need to plug in. No need for any fancy moves or stuff. Just plug in. You have a division. F is x squared minus 2, so derivative is 2x on top. The bottom is 1 plus, and then you have x squared minus 3 squared. Just walk away. That's all it is. The derivative of cosine inverse of x e to the x. Let's see what you get. All right, so what do we have? We will put the formula on the side so we know it's f prime divided by what? Sorry, negative f prime divided by? Right? F squared. Good. So the derivative is what do I have to do? Product rule. So we have to do the product rule. So we have the copy the first derivative of the second plus copy the second derivative of the first, which is 1, divided by the square root of 1 minus, and this squared is x squared e to the 2x. The only thing we can do is to kick e to the x out, and that's it. We'll leave it right there. One more problem, and then we're going to take a look at a few exercises from concepts from 311. Theotl. Theotl? Yeah. So theotl of Let's do problem 32. So f of x is equal to sine inverse of x over 4 at the point x equals to 2. Have fun. You know the procedure for the tangent line. So like you say, just do it. Right. Let's wrap this up. We start by getting the derivative first. We have 1/4 divided by the square root of 1 minus x squared over 16. And we can multiply numerator and denominator by 4 over 4, right? And get 1 because they will cancel. Now when 4 goes under the square root, it becomes 16. So we get 16 minus x squared. Right, 4 is equal to square root of 16. So when you are multiplying now that into 1 minus x squared over 16, 16 times 1 is 16, and over here 16 and 16 will cancel, so you have 16 minus x squared. We'll use this algebra again with functions in chapter 4. So that's done. So now m is when I plug in the value, which is 2, and I have 1 over square root of 16 minus 4, which is 1 over square root of 12, which is 1 over 2 root 3. Right, 12 is 4 times 3, square root of 4 is 2. Rationalize this with root 3 to get square root of 3 over 6. I also have to find the y value, which is f computed at 2, and that would be sine inverse of 2 over 4, which is sine inverse of a half, which is what I had earlier, pi over 6. So now we have that m is equal to root 3 over 6. X value is 2, y value is pi over 6. Y equal mx plus b. Y is pi over 6. M is root 3 over 6. X is 2 minus b. These guys cancel. We get the 3 there. So b is equal to root 3 over 3 minus pi over 6. That's exact. So tangent line is y equals root 3 over 6 x plus root 3 over 3 minus pi over 6. That's the tangent line. Yay! Yes? Pi over 6. I move b to this side, becomes plus b. I move pi over 6 to this side and becomes negative pi over 6.
Yeah, but isn't it supposed to be plus b here?
Plus b over here.
No. When you plug it, it's y equals mx plus b, not minus b.
Yeah, plus b. I put plus b. It's plus b. It's plus.
No,
You plugged it in originally. Like you put all the values in, but you have a minus b in the equation as well as mx plus b. Where it says pi over 6 equals root 3 over 6 times 2.
Oh, over here.
Yeah.
I would like to roll back the stream to see if this is one of those situations when something that I write disappears. So this is pi over 6 minus. Yeah, I was not paying attention later. I just went off what was there. So yeah, these need to be now reversed. This is probably one of those cases where it doesn't sync. So it just erases what I wrote. And the rest is there. Yeah, it's plus b. So this whole thing is b, which goes there, and that's it. Well, thank you for catching that. That's great. And that ends the lecture on inverse trig function derivatives. So let's restart the stream for the last part.